Now we're going to take a look at our second algebraic method of solving equations. So substitution was the first method we looked at. Elimination is the second. Again, it's more accurate than trying to graph. And all we're doing here is we're adding and subtracting the equations to eliminate one of the variables. This works nicely when you have equations that are nicely stacked up, like you see as the three examples here on this page, where the x's, the y's, and the numerical portion are all stacked up nice and in equal positions. Then we can use it to solve it fairly quickly. So we want to add or subtract these. So we want to think of our old by hand method of adding, subtracting. This, if I had 160 plus 240, if I had that, I'm going to add each of the columns up. 0, 0, carry the 1, and then I'm going to have 400 there. Or subtracting, same idea. We're not going to be borrowing or anything like that. So we have there is situations that will come up where it won't work out nicely, and we'll look at that when we get to part C. But let's take a look at the first two. So we're going to add or subtract these equations. So we got to eliminate one of the variables. If we look at these equations, the y's are both a 4, a positive 4 and a negative 4. If we added 4 plus negative 4, we would get 0. That would get rid of the y's. So we're going to add these equations. So I'm going to draw a little bar here. I'm going to put a big plus sign here, a little further away so I don't mix things up. But now I have 3x plus negative 2x. 3 plus negative 2, that's going to be like 3 minus 2. And I'm going to get myself an x. Here I have the positive 4 plus the negative 4. That's going to get me 0 y's. So I'm not even going to write it in anymore. And we set it up so that would be the case. And then I have 16 plus positive 4. That's 20. So I've now found my x value. X equals 20. Now I can sub in and find my y value. And I should have numbered these earlier, but I'll number them 1 and 2. So let's sub that into equation number 1. So sub that into equation number 1. I have 3 times 20 plus 4 times y equals 16. So that is 60 plus 4y equals 16. 4y equals 16 minus 60. 16 minus 60 is going to give me negative 44. And then divide both sides by 4. If you run out of room, like I have here, draw a neat arrow going up to where you're going to continue. I'm going to continue it right here. And now I can just continue, and I can, as a reader, I can follow that arrow and know where you're going. So I'm just left with y equals negative 11. So there I have my x value of 20, my y value negative 11, and then a nice therefore. The point of intersection is 20, negative 11. So again, we're looking for an x or y value that we can add or subtract to get rid of it. So if we look at the next case, we have 4x plus 3y equals 10. And that's equation number 1. And equation number 2, 4x plus 6y equals 4. In this case, both of them have a 4. Positive 4 minus positive 4 would get me 0. So I'm going to get rid of the x's by subtracting these equations. So I have 4 minus 4, the x's are gone, and I have 3 minus 6, which is going to give me negative 3y. And that's going to equal 10 minus 4, which is going to give me 6. Negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. I've found my y value. I will now sub y equals negative 2 into, I'm going to go with equation number 1. Doesn't matter which equation you pick, both of them will give you the same result. So I got 4x plus 3 times negative 2 equals 10. 3 times negative 2 is going to give me negative 6. So 4x minus 6 equals 10. Add 6 to both sides. 4x equals 16. If we divide by 4 on either side, we're going to get x equals 4. There's my x. There's my y. Therefore, the point of intersection, POI, is 4, negative 2. So in this case, I found it was best to subtract the 4 from the 4. And so since I subtracted this from this, I got to subtract this from this. And I do each individual piece as a subtraction. Now in the next case, we got a bit of a hiccup. Because if I add or subtract the x's or y's, nothing goes to 0. If I add or subtract those, I'm going to end up with a 1 or a 3. If I add or subtract those, I'm going to end up with a 7 or 1 again. Not helping out. So what we need to do is multiply one of our equations. And draw little arrows. Now, if I multiply the top equation by 2, meaning I multiply everything in the equation by 2 so that everything stays equal, I'm going to have 2 times x, 2 times 3y, and 2 times 3. That will be the same equation. We just multiplied everything by 2 to make them bigger. So we're going to multiply that by 2. So I write times 2 here. I'm left with 2x plus 6y plus 6. Equals 6. So I've multiplied everything together. Now, that matches up with the x on the other equation. So I'm just going to rewrite the other equation. So now that's equation 1, that's equation 2. And if I subtract these equations, I can get rid of the x's. So I'll subtract 4 from 6 as well. I'm going to be left with 2y. Subtract 2 from 6, and I'm going to be left with 4. Y equals 2 when we divide both sides by 2. There's my y value. And then finally, sub y equals 2 into, I'm going to go all the way back to the original equation 1 here. So I can use any version of the equation that I want. The one that I multiplied, the one that I didn't multiply, or this equation here. Doesn't matter. When I do that, I'm left with x plus 3 times 2 equals 3. X plus 6 equals 3. Move the 6 to the other side with subtraction, and I'm left with x equals negative 3. There's my solution. Negative 3 and 2. So negative 3 and 2. So there we have the solution to that with some multiplication of the equations. There may be cases where you have to multiply both equations to get the x or y equal. So if I wanted to get rid of the y's, similar to getting a common denominator, you could think of it, I could multiply the 3 by 4 and the 4 by 3. So I'd multiply this whole equation by 4, multiply the whole bottom equation by 3. That would allow me to get rid of the y's. They'd each be 12. But the x's was easier. Always look for the easier method. Both will work, but always try and find the easiest method. And now for a practice problem. In this question here, we have Zifnab works at a sporting goods store selling skates. A pair of hockey skates costs $58, and a pair of figure skates costs $56. One shift, Zifnab sells 32 pairs of skates. His sales totaled 1,828. Ignoring taxes, how many pairs of each type of skate did he sell? So we're going to just completely disregard any tax situation here. Zifnab, if you are familiar with Zifnab, he's a magical character, so the fact that he's selling skates in a sporting goods store for such low prices may relate to that. Our first equation is tough because we have hockey skates at 58 and figure skates at 56. We're selling 32 and then we're totaling sales. So how do these all go together? We're going to look at the two values here. He sells 32 and he had his total sales of 1,828. The two things we don't know is how many skates. So we don't know how many hockey skates. So we're going to use H for hockey skates. And F for figure skates. The total of H and F would be 32. The number of hockey skates, that should be number of, and number of. So I'm going to state what my variables represent, keep things organized. So the total of these two values should be 32. So H plus F equals 32. So there's one equation. And I'm going to make a little bit of space here just because we know what's coming. We're going to be using elimination. H plus F equals 32. So let's spread that out a little bit. Now, I got to figure out how much he made. Well, for each pair of hockey skates, he made $58. So 58H would be how much he made from the hockey skates plus 56F. And that's going to total to 1,828. So now I have two equations that I can solve. Like in our previous example, we can't simply eliminate H or F. So we're going to have to multiply one of them. It doesn't matter which one. Let's get rid of the H. So we'll multiply this equation by 58. I'm going to get 58H plus 58F equals, and 32 times 58 gets me 1,856. And then I'll write my second equation. 58H plus 56. So this was times 58. F equals 1,828. If I subtract both equations from each other, I will get the H's to 0. So I'll subtract 58 minus 56. That's going to give me 2F equals 56 minus 26. That's going to give me 15. Or sorry, going to give me 30. Getting ahead of myself. 2F equals 30. How do I get rid of that? 2, divide both sides by 2, F equals 15. So, Zifnab sold 15 pairs of figure skates, and then I'm going to go back to this original equation here, H plus F equals 32. So this was equation 1, this was equation 2, and I'm going to sub that in. Sub F equals 15 into equation 1, the original equation. H plus 15 equals 32. H equals 32 minus 15. H equals 17. So, 17 pairs of hockey skates, 15 pairs of figure skates. Zifnab sold 17 hockey skates and 15 figure skates. And then we have problem solving with elimination.